All right. So, hey, welcome, Krishna. I'm Ned Engelkey with Evotech. Welcome to our AI track. We're getting started a little late, so sorry about that. But I'd like to introduce Krishna, the CEO and founder of Fiddler. Take it away.
Hi, can you all see my screen?
Yes, sir.
Awesome. I'm sorry for the technical difficulties, team. I'm Krishna. I'm the founder CEO of Fiddler.ai. I'm here to talk about, how we are helping build trust into AI and about model monitoring and explainability and all the fun stuff that goes into making AI more responsible and trustworthy. So let's dive in. So what is the problem we are trying to solve here, right? We are hearing pretty much every few weeks how AI and machine learning have gone wrong at various different companies across the board. For example, recently we heard from Equifax that their models sent inaccurate credit scores to millions of consumers, and they got into a Wall Street Journal article. Um, in the past, we've heard companies that have used AI and machine learning, for use cases like predicting house prices or setting credit limits, getting into trouble, whether because like models have become inaccurate or have become biased over time. And this is actually a real problem that every team faces today when it comes to operationalizing AI. I don't think any of these things were intentional, but these are all the risks that one carries when you're operationalizing AI and machine learning. If you're doing it without proper monitoring, explainability, and bias detection processes and tools in place. We also have seen the what face recognition systems have gone through. Pretty much a lot of face recognition systems, face recognition software that used AI based algorithms to detect faces had undergone a lot of scrutiny in the last few years because of their inability to identify faces of certain demographics, because the way they were trained with, how they were not accurate in terms of identifying an African American people, and so on and so forth. So the problem that we are facing today as AI percolates across the enterprise is that we are in a situation where these algorithms could create and amplify biases in an unprecedented manner. We have a situation where these algorithms could basically create a societal divide that hasn't been that we have not even seen before. So the other problem with machine learning and AI is the as it gets used a lot more, it is prone to adversarial attacks. For example, I can take a model that is predicting let's say animals. In this case, it's predicting panda with a decent confidence, and introduce a certain amount of noise to make it predict a different animal here. So it's very much possible for adversaries to game your machine learning and AI models by sending noisy data that and therefore in making models inaccurate. So the problems around model bias or model inaccuracy happen because fundamentally AI and machine learning algorithms, AI and machine learning models are a black box. They, unlike traditional software where developers can go through line by line and understand the code, the machine learning models are these opaque artifacts that are trained on historical data sets to predict the future. So therefore, when you deploy these models to production, you get a ton of questions across your organization, from your business users who want to consume the models, from your support teams, from operations teams, from regulatory teams. So all of these questions today are unanswered, which results in this, lack of trust in AI, right? So our mission at Fiddler has been to rebuild that trust. We have started 4 years ago with our experiences working in consumer tech, especially at companies like Facebook, where I was building a machine learning platform for products like Newsfeed. On the right hand side, you see one of the world's first explainable AI product called Why Am I Seeing This, that shows human readable explanations of how newsfeed algorithm is working to the end user. In this case, I'm actually being told 5 reasons as to why I'm seeing this post in my newsfeed. This is because I'm friends with so and so, I'm a member of so and so group, I've liked this person's post more than others. This is basically the north star that that we are helping with enterprises reach towards by making their AI transparent, by helping them monitor their AI. So the product that we have built in the last 4 years is what we call a model performance management framework. The idea behind the solution is to help teams to monitor, analyze, explain, and improve model performance. So the MPM framework is essentially meant to help the data science and machine learning teams to accelerate, AI deployments, to build trusted AI, and improve AI over a period of time. And if you think about it, this is not a new concept, right? For example, if you go back, 10, 15 years ago, when product teams were trying to make data-driven decisions, the emergence of business intelligence tools like Tableau happened. A few years ago, when we had DevOps teams trying to understand the server utilization and data center traffic and latency issues, we had tools like Datadog emerge. So MPM is a similar visibility tool meant for the machine learning and AI teams so that they know what's going on behind the scenes with respect to their AI. They can deploy their AI with confidence, and they can build trust with it. So the 4 pillars of a good model performance management framework are continuous model monitoring, explainability, analytics of AI related data, and fairness assessments. So we believe these 4 pillars are essential for you to operationalize AI in a safe and trustworthy manner. In some ways, these 4 pillars of MPM are so important that without that, you cannot really operationalize your machine learning and AI. So let's actually dive into one of those pillars, which is model monitoring in this talk. So let's actually look at the ML lifecycle and see why we need model monitoring, right? So typically, when you think about the activities that happen during machine learning model development is you spend a bunch of time, training your data, figuring out your data design, selecting the modeling algorithms, validating these models. These are all the steps that you think that you need before you develop and deploy a model. Once the model is actually deployed, then this is where the need for monitoring the ML model emerges. So the focus of this talk is going to be how do we need to monitor this model? What are some of the human-centric design requirements and challenges that we need to consider? So as part of this talk, we basically worked with a lot of our customers, went through the use cases and needs around why they needed model monitoring. What are the aspects of model monitoring that would make them successful, and things like that. And what is the framework for us to think about model monitoring? So the domains that we sort of spoke to included advertisement sector, consumer technology, financial services, insurance, and retail. And you can see that machine learning and AI is penetrating a variety of these fields in a big way, right? So whether that's for ads personalization or speech recognition, natural language processing, or fraud detection, or recommendation models. And a lot of these applications are using AI and machine learning today in an increasing manner. Now, when it comes to the human-centric requirements for model monitoring, number one thing is to be able to preserve the human autonomy and decision-making, right? So the model monitoring system should be able to create the right type of alerts so that they can provide actionable insights to the human, the data scientist or the machine learning engineer, and at the same time should not create alert fatigue by inundating the team with a lot of alerts that could basically be very noisy. And the number one thing that we have found is being able to provide data scientists and engineers information that makes them, makes it easy for them to, deploy a lot more models. This requires the system to be aware of aspects of all types of alerts, how often they are fired, how they are presented, the user experience, the cognitive, reducing the cognitive overload in terms of how the model monitoring would work. So for example, here, root cause analysis is so important. Oftentimes when teams think about model monitoring, they also think about how to debug issues that arise when they encounter alerts and they need to troubleshoot these issues. For example, like one of the things that we have run into is the ability to do root cause analysis, where you have to take the model performance log data and slice and dice it, and being able to do drill down, so which sectors of model, which areas of the data is the model suffering the most, where the model may be underperforming, and quickly being able to identify that. The other requirement of model monitoring comes from risk management of models, governance of models. In industries like financial services, insurance, and healthcare, there is a certain amount of regulatory compliance that needs to be followed when it comes to deploying machine learning models. So you have organizations that that are set up around model governance, which want to consume reports around how the model may have performed in the last month, last quarter. And so the ability to create these reports so that you can share the dependencies of the model, why the model was created in the first place, what are the top features that are important for the model, how is the model performing in production today, are so important for these stakeholders. So the desirable property of a monitoring system here is going to be, preserving the privacy and confidentiality of these assets, protecting the user information in the training data. All of these become very important when it comes to making sure that the models are meeting the risk management and governance practices. So what are the challenges that we have found in terms of model monitoring? The questions were around what should be monitored, how should the monitoring system interact with the model, what are the technical requirements, or modules that are necessary for the model to be monitored, how do we protect the privacy of users, sort of like that, basically in the data that that is being uploaded to these model monitors. And then after deploying a model monitoring system, how do we make sure that it is reliable in terms of catching performance issues? How do we make sure that it can quickly help us remediate actions, quickly help us suggest remedial actions? And how do we debug these model monitoring systems? So the final questions is it going to be is once we have a model monitoring system, how is it helping my business? For example, is it helping me catch business critical issues with respect to my models, so that I don't suffer revenue losses or reputation damage when these models go wrong in my production? Does it give me insights around where the model might be underperforming, which segments of data maybe it's underperforming, so that I can go and fix these things? So let's talk about a few different techniques, a few different aspects of model monitoring that are essential here. Number one is ability to monitor data drift, right? So there are basically two types of data drift when it comes to monitoring your models. Number one is you have trained a model. When you train the model, imagine you have some examples that you're classifying a model that is identifying yellow versus blue dots here. So you learn a decision boundary that separates these circles nicely. And when you deploy to production, you find that the production examples are behaving differently. So what you may find is the concept has shifted, where the relationship between the features and the target predictions have changed. So therefore you're seeing a concept drift happen in your production. And then you can also see a situation where there can be data changes that are where the relationships are not changing, but there are fundamental data changes that you're seeing in your features and labels that you need to catch. So the ability to be able to separate real drift from virtual drift. In certain cases, what will happen is you might see data changes that are not affecting the decision boundary, in which case the data drift may not be affecting the model performance. For example, here the yellow dots are all on one side of the same side of the decision boundary as they were trained. So there's even though they are shifting in terms of their distribution, they're not really affecting the model performance. So being able to separate the virtual drift from the real drift is going to be super important for a model monitoring system. So what would be a real world example of these different types of drift? So for example, let's say you have a loan application model, that you have trained on a certain type of good loans and bad loans on your historical data, and you've deployed to production. So now suddenly the income level that was considered credit worthy in the past is now become riskier. This could happen because of Fed increasing interest rates or unemployment growth or other economic factors that could be influencing the society. Now this actually is concept drift because it has now changed the fundamental relationship between the input variable income and the output variable, which is the loan risk. And in this case, you may have to retrain the model, right? And the other could be a label drift, where suddenly because of some business changes or business decision, we are seeing a large proportion of creditworthy applicants that are showing up. So by the time we deployed the model to production, the distribution of creditworthy applications is really changed, and maybe because we opened our business in new locations, and we are seeing a vast number of creditworthy applications starting showing up. And that's actually the label drift that could affect your models. The other could be feature drift, where let's say the model was trained on a certain type of income distributions, but then what we see is when we deploy to production, that those distributions are changing between regions and between the training and production setup, and that could also influence the model performance. So the key is to figure out what is real change and what is actually virtual change, right? A real change could be where a business, you've launched a product in a new market, or some sort of event like COVID has happened, or Fed has increased some interest rates, that has really made the change between your model inputs and model outputs, and which means that you may need to require a new model. And there can be a virtual change, in which case most of these data shifts are happening because of incorrect data, data quality, data engineering issues, where incorrect data is entering into the models. For example, let's say values of age and debt to income ratio are swapped at the input level, so now you're seeing incorrect values to the model. Or you may have an upstream pipeline that is basically inputting incorrect data at the source level. For example, a website form accepts basically leaving a field blank. So these issues need to be caught during model monitoring time, and there are several techniques to catch them. One popular technique is to be able to measure using the ground truth, how the model is performing. For example, let's say you do have the ground truth, like how many good loans are you approving. Let's say you're collecting the first installment data, or let's say in the case of fraud, if a particular transaction was fraudulent or not. You have some human label data, or in the case of recommendation models, you have click-through data that you can use as ground truth to measure model performance. So you have techniques, you have a lot of model metrics that you can use to measure the underlying model performance through performance monitoring. But the real problem will be when you do not have the ground truth, right? A lot of the times your ground truth can arrive later, which is where you need to monitor the shifts in distributions of your features and production and your predictions. So in this case, for example, let's say I want to look at how interest rate as a feature is distributed in production and my training setup. So you can quickly see, like there is distribution differences between production and training setup, and you can use a number of these different techniques to monitor these shifts and alert on them. Similarly, if you want to monitor for data quality errors, things like being able to know missing values, range mismatches, type mismatches, schema mismatches. These are data errors that slowly degrade model performance, and they look like data drift. And so these are issues that you could actually need to catch. These are issues that can catch virtual drift, and can actually hurt the model performance. So this is important to monitor as well. And finally, when you kind of put all of these things together, here is like a dashboard that you can build through Fiddler, where you are monitoring the outcomes, the model's predictions, and monitoring the drift in those outcomes, and then you can attribute those drift to the underlying inputs. So for example, when the model is drifting, you can say where is that drift happening, which of these attributes from in your model are having the maximum impact on this drift, the drift impact, and then being able to look at the models, for each of those inputs, how is the distribution between the production and training setups. So once you have that model monitoring, what you can do is you can, let's say if there are data quality issues or data schema changes or violations, you can quickly go and update the pipeline. This is a much much quicker fix to go and figure out the model performance and without retraining the model and root cause and troubleshoot it. But if it is indeed requires a model performance, if it's indeed a concept drift or a real data drift, which means that you really need to retrain the model, you need to go and retrain the model, refresh the data, look at the business logic, and collect the new training data set and retrain the model. All in all, you still need to be able to keep track of all of the models, the production models and the various different versions of these models in one place. So what we have built with Fiddler is a product that can help you do these things. It's a pluggable service in your workflow. It can work across a variety of different models that your data scientists can bring. And it provides a single pane of glass to monitor performance of the models, monitor drift, data quality issues, helps you understand explanations behind the predictions, and do root cause analysis and fairness analysis of these models. And so if you want to learn more about this, please feel free to reach us at info@fiddler.ai, or you can also reach me at Krishna@fiddler.ai. And if you have any questions here about model monitoring or explainability, I'm happy to answer right now.
Thank you very much. We're much obliged for your presentation today and for your support. Everybody, next up is Matt Fornito from Summit Data. Please join us in that room. We'll see you there. And thank you again, Krishna. I hope you have a wonderful day.
Thank you so much. Bye-bye.